Okay. So,
So
well,
just to clarify, the exam's open book,
yeah,
not open note.
right. Open book. You can use your books as long as you haven't written through them. But I got no way to verify that. I'm not going to come over to your house and check your textbooks. Um, it has been closed to homework and notes. When we set it up in the testing center, they don't allow the homework. You can't take any files in with you. Um, we did allow the textbook, and actually at the testing center, we gave them an electronic version of the textbook that they got to use, which is kind of unfair if you're using a hard copy and then all of a sudden you're forced to use this electronic copy. And you're also able to use the help features inside of SolidWorks, which you just type in help with a space and then the name of the command you want help with, and it'll pull up and give you all this information. I use this one quite a bit because I only have 2 functioning brain cells and I can't remember all this stuff right here. So I have to call this up quite a bit to find out the proper coding for the colors and styles of the points and the styles of the lines. And if this doesn't give you enough information, you are also able to use the documentation. These are all within MATLAB, so feel free to use them if you want. And then I guess there's only a couple here the last week. I showed them something. If you get, as you're cruising along during your homework, you get a little brain cramp and you're tired of working, just type in 3 little letters, and hit enter, and then hit the arrow up button and enter again, and just repeat as often as you like. I don't know how long it'll go, but it goes for quite a while. So, okay, so anyway, this is the review for the what are we? We're fall semester, aren't we? A fall semester 2020 exam 1 for 1030 and 1040. What I'm going to do is I will go through here and work this exam, which was one I gave to my students last semester during. It says spring, but I think I did that in. Oh well, it doesn't matter whether it was spring or summer. I should still be able to do it without any problems, I hope. And then once this is done, I will process the video. I will post the video on Canvas. I will also post my solutions that I created during this video for you to look at. I will also, once I'm more sure on the format of the exam, will post something similar in format as a practice exam. If it's going to be the 6 questions on a quiz with a 10-minute time frame, I will set something up like that, or just another exam with solutions. So anyway, okay, so start off, make sure you put your name. Section number doesn't matter because this is the only section. Date, if you want to put your date on there so you know when you took the test, that's entirely up to you. I just need to make sure you have your name in there. Yeah, I grade these one at a time, so it's really not that big a deal, but it is nice to go up to the top and see who I am for when I'm saving files. And make sure you note this too, that not all equations in here are in proper MATLAB form, which means you can't just copy and paste and expect them to work. So problem number 1 is worth 15 points. It is create a vector named x with 100 regular spaced values starting from 6 and ending at 30. So we know that it's supposed to be called x, and because it told us how many to do and the starting and ending point, the easiest way to do that is with the linspace command. We're going to start at 6 and end at 30 with 100 elements, and we won't suppress it. Okay, part B. Create a vector A having 6 values between 0 and 10, including starting number 0 and ending number 10. Okay, I don't know what makes that any different than the other one, but because here we go. Because here's the difference in this one, because This one, you need to start at 0, which this one will start at 6, but because there's 6 values, you can't. Let's see. Lin space. No, okay, yeah, 0 and 10 with 6 digits, and we'll run it, and there's a 100, so there's 2, 3, 4, 5, 6. So okay, so that was just a repeat of that one, so that's cool. Okay, create an array B. This first row contains the values of 5 times A, so we're going to need square brackets here. The first row is going to be 5 times A. And whose second row, what? That's supposed to be 5, you idiot. Don't call me that, it hurts my feelings. Okay, the second row we'll do with a semicolon is going to be 5 times A minus 18. And I don't want to see all these up here, so I'm going to suppress that. And that looks right. Okay, and then the last one is create a vector W having 20 logarithmically spaced. Ooh, you guys should be impressed I said that correct the first time. I'm not going to try to do it again. Values ranging from 100 to 10,000. So because it's logarithmically spaced, we use the log space. And we are going to start at now with log space. It is the log of the values, so not minus 2, it's just 2. And 4. My eyes can't focus on that. Yeah, it looks like those zeros.
I think it's 4.
And we want 20 spaces. And so there we have it. So if we multiply that by 1,000, that puts that at 100, and that puts that at 10,000. Oh, sorry. I've been suffering from a cold since last Thursday, so bear with me. Okay, so there's problem 1. We just earned 15 points. Woo! Okay, cool. Let's unsuppress that so it'll show next time we run. Okay, so here we go. Problem number 2 worth 15 points. Power delivered from a voltage source Vs to the load resistive RL is given by the expression of P equals I squared times RL, where I is the current supplied to the load. The current supplied to the load can be calculated by Ohm's law as that big, long, hairy equation that our electrical engineers in this course will recognize. This was a poorly formatted exam that should have been put like that. Okay, for VS20, find the value of the load resistance that would result in the maximum power being supplied by source to the load. Okay, so we want to find what load resistance, ooh, and that's a nicely spelled word, that would result in the maximum power being supplied. So we got to, okay, so we're going to calculate P and then find the what largest P has a value, or the RL value at largest P. So first, if we got to do is calculate, let's define our variables. We have VS is 120, and that is in volts. We have RS is 50. That is in ohms. And we're going to go RL is equal to 1 to 100, and we'll go ahead and space them at 100. And what is our units in RL?
ohms.
You would think so, wouldn't you?
Yeah, it says 1 to 100 ohm.
Oh, it does right there. Yeah, see? I'm just seeing if you guys are asleep or. Okay, equals VS divided by. Okay, we can't use a divided by. It's got to be a dot divide because RL is a vector. RL. Okay, so now we have our I. Now we can calculate our P. Our P is equal to V, not W. This isn't a Volkswagen. Um, uh, where did you get VS? I don't know. I was on drugs. Oh, it's V dot raised to the 2 dot times. Where'd my times button go? It is RL. Okay, so now we're going to find our max P and its location. And again, location is just a variable. It is not a function. And that's going to be a square bracket. And so does that one. Why did you put curlies on there? Because I wanted to see if anybody would catch it. Oh, I caught it. Oh, well, you are so smart. We're going to do max P. And then our RL at max is equal to, and we want to find what is in the same location as that. Uh-oh, somebody left me. Am I that boring? Yep. And then let's just come down here and report our max P and our too many capitals there. RL max. Boom. What? Oh, I capitalized the M. Don't do that. There we go. So our maximum power is 72 at an RL of 50 ohms. So the trick on this problem was that you needed to calculate I before you calculate P to find the maximum P. Okay, I'm moving on. Ooh, this one's worth 20 points. Okay.
Part B, it looks like, too.
Oh, there's a part B. Oh, good. I'm glad you said that. Ooh, okay. So seeing as how we're plotting, I'm going to come up here. I like smooth plots. So I'm going to add a whole bunch of data points. And that may change our, nope, still nice solid 50 on there. Part B is to plot the power supply to the load as a function of the load resistance. So we're going to do RL and P. Use the mark point. Okay. And we should do an X label is what is our X? Our X is
your resistant, your load resistance, whatever it is, resistance load.
Resistance. Oops, and that would be in ohms. And our Y label would be power, and that is in voltage. No. Power is not voltage. Power. Well, it doesn't give us power. It is in, and I'm too tired to think. Okay, so here's our plot. And then tools, insert text box, and our maximum power is up here at right there. Would you quit doing that? You're really beginning to bother me. Oops. Okay. So there we go. Any questions, comments, wants, needs, desires, concerns, complaints? Oh, there's lots of complaints, but please hold them till the end. Okay. Problem number 3 is worth 20 points. This one should be very familiar because I believe this was taken directly out of the homework. Create variables named x and y are evenly spaced vectors with 100 elements each from -5 to 5 for I did what? Let's go -5.1 to point, you idiot. I'm going to tell you, keep calling me names. Ooh, let's make that even smooth. I like smooth plots.
Would we need to do lens space on this one as well with the 100 elements?
Did it say? Oh, it did say 100 elements. Yes.
Okay.
I just checking you guys, making sure you're following me here. But that's not a very smooth plot. Y equals X. Okay, use mesh grid to make new. Ooh, we like mesh grid, don't we? Yes.
I think you have K in front of that lens space.
I do, because I was working in kilograms. Okay. We're gonna overwrite our existing variables and make them bigger. Mesh grid with X, X comma Y. And we're gonna hide that. Okay, so completely, yeah, you guys should be familiar with this problem. So we're going to do a subplot, and it wanted a 2 by 2, and then the first one we're going to use mesh, and we're going to mesh X, Y, X, X, X. Come on, you can do it. I know you can do it. Oh, you didn't calculate Z yet. Ah. Okay. And we're going to borrow this down here. See, this is not a MATLAB expression, so we're going to change these to an X dot times a Y dot times all that and that and that, and then we need to dot divide because we got more of those in here. And then we need to make this a little z. And then we can do a title. And axis labels. Okay. Labels on axis labels on this one is kind of silly because what am I going to do? It's X. And it's Y. And by default, that's what MATLAB will put in it anyway. Okay, so let's see what happens here. Oh, we're going to have, oh, look at that. Isn't that just gorgeous? Okay, so now we're going to cheat and go, our second one is going to be 2, and we're going to do a surf. And don't tell me that. Who put the G in there? Here we go. And then we need contour. See if you can do this one without making a mistake. I don't think so because I are stupid. And we'll put this down in location number 3. Cool. And yeah, like I say, most of you, or actually all of you, should know this one problem because you just did it on the last homework assignment. Contour F.
Did that first plot need to be a mesh, or were there other options that would have worked for that?
Well, it said right there, use mesh.
Then it would be true.
Yeah. I would probably, because it's specifically stated mesh, if you didn't use it, I'd probably take 90% off your test. I mean, just a point or two. Plotting function creates permission. Okay, that's it. And then this one here, we want to start with a CLF just in case we ever have to plot again, because otherwise the plots will all come down here in this spot right here. Okay.
Would you ever add like close all in there?
You can if you want.
Okay.
But the first thing I do when I grade these is I do a find, and I look for close all, I look for pause, I look for figures, and I delete all those because it interferes with the way I grade. But it doesn't mean you can't use them. If you want to use them, go ahead.
Okay.
Okay, surface area and the volume of cylinder is given as S and V respectively, where R and H are the radius and height of the cylinder. This one's worth 15 points. Write a function. Okay, when it says write a function, that means a user-defined function called cylinder that requires 2 inputs, R and H, and returns the corresponding surface area and volume. So what I like to do when I'm doing these kinds of problems on exam is I'll copy that and come down here where I'm going to write my functions. Functions, come on, you can spell functions. There we go. It's equals cylinder, and I had an R and an H, and I'll copy that there so I don't have to keep scrolling up to the top to see what it is I'm doing. Now, if you wanted to create a new M file to do your functions in, that's fine too. Oh, that's one thing. Yeah, a little late now, but okay, when I get done, I don't know if y'all are familiar with Live Editor, but the exam will be delivered to you in the Live Editor format. And so I'll make sure and cover that before. And if I try to leave before showing that, make sure somebody scream at me and say, "Hey, stupid, show us what Live Editor is." Okay, so we got to have 2 results here. So we got to have an S. Oops, got to have a square bracket, an S and an H. So we're just going to say that S is equal to 2 times pi times R dot raised, just in case somebody sends it a vector, plus 2 times pi times R dot times H. And then V is equal to pi times R dot raised 2 dot times H. And because we're doing this in our main script file, we have to end with an and. So there we have it. And then we'll come back up here to this problem and solution. We'll test our function. So I'm going to do a couple of tests. I'm going to do a surface area equals, I think I capitalized that, right? R and H. You didn't define them. I know. I put the horse before the cart. You're supposed to put the horse before the cart, you dummy. Man, you are so critical on me tonight. Okay. So this should just return one value. Boom. There it is. One value. Now, if we do a surface area 2 und volume. Oh, I tell you, I'm so stinking tired. Equals, and then we just copy this down here. We should get 2 answers back. Nuh-uh. What did you do? What did you do? Oh, I got a V and an H. Ah, you're an idiot. See, here we go. So to get both replies back, we need to assign 2 output variables to the output of this function. Okay, I'm gonna go cry in the corner for a minute. What do we got? 3 more problems. Any questions on that problem? Or did I butcher it so bad you're clueless as what was going on?
Just quick question. With like the functions, do you have to like leave a statement saying your functions down below? Is that pretty given?
You can if you want. Because if when you submit your exam, if I don't see an extra file, I will go to the bottom of the file looking for it.
Okay.
Create an one of these functions called myfunction equal to 10x squared minus 100x plus tree. Okay, we can do that. So my function is going to be an anonymous function. Therefore, we start with an @ and we're going to have a variable of x, and it is equal to 10 times x, and we'll make it in case we want to send a vector to it. If you don't make it able to accept the vector and it doesn't say to, you'd be fine. But if it does say to receive any input, then you need to make sure that it'll receive a vector or matrix. Okay, so there's that. Use fplot command to plot from 4 to 6. Fplot. Oh man, it's been a while since I fplotted. Fplot. My function and it's going from, I think this is supposed to be square. I guess we'll find out here when we hit the enter button and it goes kablooey. Kablooey. Oh, look at that. I did it right. Woohoo. That's one for me. Woohoo. I'm dancing in my chair in case you can't see. Determine the approximate location of its minimum. The approximate location looks very close to 5, but it'd be hard to say. Yeah, I bet it's 5. Okay. Use the fmin boundary function to find the minimum function value in this range. Okay, so min function value equals f min boundary of my Function, no, there's no J in function. Promise. What? Don't give me that. And we're going from 4 to 6. And requires 3 inputs. Oh, there we go, 5. See, I told you it was 5. See, I can see that right there. It's 5. Okay, so now this one didn't say anything about titles and labels, so I would not dock you for not doing so. But if you want to do it, that'd be a good habit to get into.
Quick question on that one. The first statement, the my function, after the equal sign, is that an add symbol? Or
That is an at symbol.
Okay, could you explain that to me real quick? I'm a little confused.
That tells MATLAB that this is an anonymous function, which is a function that is written right here within your code. I'm not sure which page in the book it covers anonymous functions.
Sorry, I was just working on one right before this. Page 2.
Oh, I found it. Oh, I passed it up. I passed it up again. Somebody keeps taking the wrong page out of my book. Anonymous functions is on page 226 of the textbook. But in order, basically this is just a command to MATLAB. It says with the @ sign that this is an anonymous function, and the things that you put inside of the parentheses are the inputs to that function. And then you put a space and their function follows afterwards. This will only work on a one-line type situation. You can't have multiple lines, like we did down here.
Like you can put in some what's it called? Variables in there somewhere.
Right. Yeah, we could put some coefficients up here. We could have an A. Whoa, dude, what did you do? I just hit the A button. Then where did it go? It went to lunch. So, you could put coefficients up there, but they have to be defined before they get to the function. Okay. Does that help?
So are you saying that an anonymous function must have one input and one output? Is that what you mean?
Well, you can have multiple inputs. It's just you can't have multiple lines. You can't. Where here I've got 2 lines doing calculations inside of this function. To the best of my knowledge, you can only have the one line inside of an anonymous function.
So when we're talking about anonymous function, we're just assuming that it's just a series of calculations just for one set of calculations.
Right.
Versus like multiple equations being combined. Okay.
Correct. And once I hit this clear button down here, this is wiped from the memory of MATLAB, and only way you can get it back is to rerun it, whereas these functions are always available.
I guess I'm a little confused on why you would create an anonymous function and not just do the calculation.
To be completely honest, I've been confused with that since this was introduced. I mean, it just seems a lot easier to do that. But oops, that's not what I wanted. Control Z. Somebody somewhere along the line says, "Hey, it would be cool if we could make an anonymous function." I've never, in the 20 years that I've been working with this program, and the 15 plus years that I've worked as an engineer designing pipeline tools, I have never come across the need to create myself an anonymous function. So, if you guys get out in the industry and one day you create yourself an anonymous function, send me an email. I'd like to see it. Okay, problem number 6, 15 points. A company must purchase 5 kinds of material. The data file, oh, I didn't give you guys a data file. For shame, for shame, for shame. Quality purchase.dat gives the price the company pays per ton for each material, along with the number of tons purchased in the months of May, June, and July. That's a lot of tons. Use MATLAB to answer these 3 questions. Oh, these questions, because there's 4. A, B, C, and 4. Okay, so first thing we needs to do is load the data file, and I'm going to hope that I have mine set up to go to a different file to look for data files that aren't in my current folder, and it must be there because it didn't scream at me. It's there. Okay, so if y'all want, I'll attach a copy of that data file so you can have it.
If we don't get something like that on the test, should we just make one?
If there is not
Like a
one on the
matrix?
exam, I will be available. Just send
Okay.
me an email saying, "Hey, stupid, we need this file."
Okay.
And be blunt. I mean, I can handle it. I got a good therapist,
Okay.
and I'll get it to you.
Okay.
And if you're taking it on Friday, I'm off every Friday now through the end of the year. Woohoo! Woohoo! So I can get it at any time on Friday, and I'm basically sitting in my office the rest of the time. So I can get it to you anytime you need it. Okay, create a 5x3 matrix containing the amount spent on each of the items for each month. A 5x3, 5 rows. Okay, so I'm gonna assume that. Well, sorry, you all know that I'm not a typist. It's very blatantly clear, and I'm not ashamed of it. Well, I am, but it doesn't mean no good. So I'm gonna put that into a vector that's a lot easier for me to deal with. So spent is going to equal the data, and I want all the rows from columns 2 to the end. To the end. And that should give me a 5x3. No. Oh, that's the materials 1. Okay, so sorry. See, that's why I did that. This one, 3 through end. There we go. So that gives me my 5x3 of the amount spent. Okay, so that gives me, that's not spent. This is tons purchased. There we go. And then we need to create a, what are you doing? I don't know. I don't know either. A price. I don't know if this is going to work. We haven't learned that stuff yet. Just keep going. They don't know the difference. Okay. I tell you, some of the conversations that go on inside my head would scare the bejeebies out of a lot of people. So actually, I don't think this is going to work this way.
Because I think we need to break it all up, right?
Yeah,
In the different columns.
yeah. In later chapters, we learn how to do this, but we haven't learned that yet. So I'm going to change this to a May with only 1 capital letter in it, and this is going to be 3. June is going to equal data and all the rows from column 4, and July, that's the month my brother was born, and there's going to be all the rows from column 5. Okay, do we have a clear? Yeah, we have a clear. I'm going to add another, put them in the right order, stupid. There we go. Okay, so now they're there. So now we're going to create our spent file. That's going to equal May dot times price. But oh yeah, they're column vectors, so that will work. And a June dot times price, and a July, only one Y in July, dot times price. We're going to close that, and we're going to, we don't want to see this anymore. We know they're.
I think the main needs the whatever it's called.
Yeah, the dot there.
Yeah.
There we go. We transposed it. We didn't multiply it. There we go. So there's our 5x3 of the money spent. What is the total spent in May? Well, oh, that's easy. We can do that easy. The easy way we're going to do this. How are we going to do that? I'll tell you how we're going to do that the easy way. Okay. Monthly spent is going to equal a sum of spent. And then May spent equals, boy, you got some really long variable names there, you idiot. I know, but they're very descriptive. 1. And then we're going to cheat. June is going to be 2, and July is going to be 3. Boom, chicka boom, chicka boom. Okay, so y'all know that when you do the sum on a matrix, it returns a vector of the sum for each column, right? So that's what I did here. So this first column, second column, third column, which is May, June, and July, and then I just pulled out each month and assigned it to a variable so we know what we had spent. Okay, what total spent on material in the 3-month period?
And we gotta reverse it doing the other. What's 1, 2, 3, 4, 5, right?
Oh, so it wants to know how much we
Material
spent on material 1, material 2. Okay. Yeah, then we got to do some transposings and oh, good grief. So that will be a mat spent equals spent. Come on. Transposed. Summed. Sum. We need sum. And that should give us that's for each material, and then yeah, okay, and then if we multiply that by price, boom. That's a lot of money spent. How did we get clear up there when we were down here? That ain't right. Oh, wait a minute, because we double spended it. Man, I tell you, I am so tired. Because this already had the price spent in it, you idiot.
Yeah.
So this is our for the first one, the second one, third, fourth, fifth. That's what we spent for. And if you wanted to pull those out, you can. I'm pushing your guys' time here. It's already 9 o'clock, and we still got one more problem to go. And then to get to the price spent on all of them, we'll just do
another sum of all that sum.
Yeah, price all equals a sum of I think if we go, no, we got to do the monthly spent. Not plus, you idiot. Because spent just gives us a total for each month. So this gives us a total. This is probably the most confusing problem on the whole exam. Okay, problem number 7. For all these who are still awake. Maximum height g and another thrown for the speed v at an angle theta to the horizon is given by the expression that consider the values of velocity in meters per second and theta in degrees are v theta. Create a table showing the velocity and height. Plot the velocity and height. Okay, so that obviously they want us to use mesh grid here because we got more v's than we have thetas. So we'll come down here and start off by the heater just came on. We don't need units. This needs to be in square brackets, and this needs to be in square brackets. Okay, so let's square brackets again, and we'll just overwrite the variables so we can cheat and use that equation. I don't know if anybody from MATLAB's popped in yet. No. I told my MATLAB students that I would be online tonight doing this review, so it may run late. So and then we're going to borrow this equation. V has to be
Square root, yeah.
sine theta, and we gotta have a dot there, and
then the divide, no.
we got some error somewhere. Oh, we gotta have a multiply in here.
Multiplication with a G.
Yeah, gotta multiply in there. There we go. Okay, so V's a vector, theta's a vector, G's not, so we don't, but I mean, it doesn't hurt to put an extra dot in there anyway. If we run out, I can go to Sam's Club and get some more. Okay, obviously no errors because I just ran the code and it just, oh, there's the error. There we go. Okay. Create a table showing the velocity and height. Okay, we can do that. We're going to do a table. Have we learned the inputs yet? Outputs? F print and all that?
I don't
Not
yet. Not yet.
No, that's coming up next.
Normally I've just done like V with the transpose.
So
H transpose.
we want V first, but this is going to be our see that there's a problem because I want my original V back, so I'm going to capitalize this one because this V is now a vector or a matrix, not a vector. And we'll do the same for theta just in case I need it later. So this is going to be V comma, oops, transposed, und an H transposed. No.
Oh, the comma, sorry. After the
Oh,
H.
yeah. It's a freaking. Here we go. That's not right. I got so many digits in there. V, H has too many digits. course, I guess there's going to be, oh, and we got an error here too. Somebody didn't scream that one out. But yeah, that would make sense because we're going to have 4 different heights depending on the theta. So there should be 5 columns there. But because theta is in degrees and not radians, we need to use the degree command or transpose it to, or convert it over to radians.
Yeah.
Okay.
What's the apostrophe going to do for us in the table?
The apostrophe down here transposes this vector. See, untransposed, the vector is a row vector. But when you transpose it, it turns it to a column vector. And this allows me to put this vector next to this matrix inside of a table.
Okay.
And I think it's the very first chapter after the exam, you learn how to format your tables, putting headers and titles and, plotting them out really nice. Yeah, it is. So, and you can really dress up that and make it look nice, but I don't expect it on this exam because you haven't learned it yet. Okay. And then the final thing to do on this masterpiece is plot the velocity versus height. Add legends, labels. I think we can just do a simple plot of v comma h. Is that going to let us do that? Wow, look at that. Isn't that a beautiful plot? Where'd it go? Oh, it's back here. So there's your plots. Add legend. Legend.
Like 45, 60,
yeah, something
75,
like that.
and 90.
45, 60, 75, and 90. Oh, 90's got to be. Labels. Well, I mean, yeah, I don't want to keep you guys here for silliness like this. I mean, well, it's not silliness. It's very important stuff. Labels. X is what was X at theta.
X is velocity on this.
Oh, it is, isn't it? What? Oh, that's right, velocity. I knew that. I was just seeing if you guys are paying attention. And I'm tired. I'm so tired. Comma. And the Y label is height. H-E-I-T. And I'm guessing that's going to be in probably meters because the velocity is in meters per second. And the text line of my name, I'm not going to put my name in there.
You can just do like text 212 or whatever, 12.2 or something like that.
I think X is, yeah, 12, 2, and then, oh, wait a minute, I've been going by Skippy lately. Yeah. Oh, there I am, clear down at the bottom. I need more than 2. Wrong button. There we go. Skippy, clear up here. Okay. So that was a little brutal. Any questions, comments, wants, needs, desires, concerns, complaints? And complaining about me being a complete idiot is not valid at this point in time.
So for anonymous functions,
Anonymous
you
functions.
created one,
I did.
and then
Where did
like
I?
if you needed to use it again, would you just type in like? I'm confused on how you would use them.
You'd have to like save it
Well, yeah.
and
Okay.
then pull back.
So we've written this anonymous function, and that will be valid until you use a clear command. So as long as we, if we commented out all these clear commands, comment that one out, comment this one out, we could come down here and what was the name of that function? My function. We could call up my function and pass it my v vector. You're an idiot. I know. And that should, undefined, because I haven't run it since okay, here, let's run this.
Yeah.
And now if we come down here, I should be able to run that and see it still ran this because I hadn't cleared the memory out. So as long as you don't clear the workspace, that function will be in the memory and available at any time you need it.
Okay, thank you.
Yep.
Could you quickly, in the last problem with the use of the mesh grid, again, I'm a little bit not necessarily comfortable using it that often. I'm just explain conceptually
Sure.
maybe the purpose of it.
So what mesh grid does, you'll notice V here has 1, 2, 3, 4, 5, 6 elements in it. And theta only has 4. So what the mesh grid does is it takes these two vectors and creates a new matrix for each of the variables that you put in here that consists of these values. So if
Makes like a row, one of them a row function where
right,
it'll be like,
so
and then one of them a column, just because you have to have the same
right, you got to
dimensions.
have the same dimensions in order to multiply them together. So we got here V is 10, 12, 14, 16, 18, 20. So after we've run the mesh grid, we now have 4 rows of V. And we have 6 columns of theta. So now when you multiply those together, they're the same dimensions, so they will multiply.
Okay, so essentially just when you're dealing with two different vectors that have a difference in the amount of,
Right, of different size.
yeah, okay.
And it also, we don't teach it in this class, but it also works for matrices that have different size. But
Okay.
now you're getting into some complex calculations that we don't get into in this class.
Wished I had it for some of my math classes though. Just kidding.
Go talk to Holly. She wrote the book. You all know Holly Moore, right?
Yeah.
I don't, but
Oh.